Agriculture on the move.
Agricole mouvement.
Agriculture on the move.
Agricole en mouvement.
Agriculture on the move.
Agricole mouvement.
Agriculture on the move.
Agricole en mouvement.
Hello again and welcome to the program, Agriculture on the Move. My name is Phillip Sydney. Today our topic for discussion is greenhouse production of production. With me are three distinguished gentlemen who are well versed in that field. And next to me is Mr. Elvis Herelle, who is a consultant when it comes to greenhouse technology in St. Lucia. Next to him is Mr. Quint Odlum, who is an engineering technician in the Ministry of Agriculture. And next to him is Mr. Thaddeus Constantine, who is an agronomist attached to the Ministry of Agriculture. Welcome to the program, gentlemen.
Yeah, welcome.
Elvis, I want to start with you because going back in history of greenhouses, oil, what we call greenhouse in St. Lucia, which I think came in here as a result of the French people from Martinique. What was the purpose of the introduction of that so-called greenhouse tunnel cover in St. Lucia?
Okay, during the late 70s, early 80s, a lot of work was done with the French mission under the system was known as the Farming System Research. And out of that, it was realized that one of the problems that a lot of the vegetable farmers, especially in Region 6, were having was associated with the weather. In that during the rains, it became extremely difficult to produce vegetables, primarily cabbages, tomatoes, and sweet peppers to a lesser extent. So having realized that was the situation, we came up with the idea that if we were able to produce healthy seedlings, the farmers would have stand a better chance in harvesting a crop. So we quickly brought in 2 greenhouses, and that was assigned to the Bellevue Farmers Cooperative in Myers Bridge, where we were producing seedlings. But we then realized, look, because of the success of the seedling production in the greenhouses, that the technology could have been extended to actual production. And we came up with a program where we installed a few greenhouses with the farmers, and during that time we were picking up data, collecting data, and seeing what needs to be done to kind of perfect the use of the technology during that period. And
what are some of the success stories in that period?
Well, the success stories during that period, as I indicated, was a good, healthy seedlings, right, which allowed the farmers to produce a healthy crop. Then we moved during the time of the actual production in the greenhouses, farmers were able to produce tomatoes and peppers and cucumbers during the middle of the rainy season. So when these crops were generally not available during the peak rainy season, the technology allowed the farmers to produce these crops during that time.
Okay. Quinn, what are the additional advantages of the greenhouses? I know they're looking in terms of the tomatoes. There were physical dropping of the flowers by rain, and of course with that cover that prevented that, so you had more. But there are other advantages.
Yeah, some of the advantages of the greenhouses, we could refer to them as protected agriculture. Okay. Meaning that it's an environment where we have a lot more control over what is happening. We are protected from the rain, we are protected from the sun, we have certain level of control over the temperature and also the feeding of the plants. So we use a lot of fertigation where we can actually give the plants the required nutrients. So it's a much more controlled method of agriculture. One of the main benefits is that you could actually predict or determine your outcome. Whereas in the open field, it's not that easy.
Okay. But during that period, why is it that there were some farmers who were not able to continue with the production under the greenhouses? Because a survey was done, in fact I was involved in that, and there were a number of greenhouses. Out of the 100 of greenhouses at that time that was established, we had probably about 50% who were in production, and I don't know if you're aware of that, but what were the main problems coming from this?
Okay, from my involvement, I could safely say that in all the greenhouses that were established with the farmers, there was only one greenhouse where we had a technical problem. Technical in terms of, apparently there was some reaction, I think, to the microenvironment and the plants. And actually, that was on the property of a retired extension officer. Other than that, all the greenhouses that were established proved successful. In my mind, the problem is one of management. The bulk of those greenhouses were established on what you may call farmers who are kind of resource poor, or the resources is not, they're not lavishly blessed with financial resources. Now, bearing that in mind, if you produce the bulk of those greenhouses that were not in production was because of plastic, the covering.
Okay.
Right? At this point, a sheet of plastic is over $400. Right? Now, the average farmer does not have, in these days, probably about $1,000, $1,200, $1,300 to buy plastic, to pay to put it up, and that kind of thing. So, in my mind, that is a problem. Right? Also, there are times when after your irrigation lines, right, based on the quality of the water that you use, it would have been clogged, right, and that creates a problem. So for me, I think it's mainly a problem of management. The other little problem too is that succession planning. Some of our farmers who had those greenhouses, I mean, they were 60 plus, for example. Well known is the Audi.
Audi was the one,
right?
Good success
right.
stories.
Yeah, I mean, a success story, right? But with age, right, he had to give up the greenhouse. I mean, working in the greenhouse, and nobody took it over. So for me, these are the main issues that impeded and the continuous production of the greenhouse. The other one is health.
Yes, we understand that. But going forward, do you think, Taddy, that the present greenhouses that were used, the tunnel greenhouses or the cover as it were, is it adaptable going forward?
Okay, these greenhouses were introduced without any research being done on how suitable they were for the climate where they were being put. They were actually quite productive because they allowed the farmer now to do a lot more crops in a smaller area with a lot more control, like Quint said, because he now was able to put in his irrigation and put in a number of things that would normally not be available in the open field. However, when we look at global agriculture and we look at production levels, our production levels on this island are very low. For us to be able to compete and really make this, this industry what it's supposed to be, we need to start looking at more innovative designs. Designs that are geared towards reducing the use of energy and also providing the plants with the best environment possible. We've been focused on domes. However, domes have been proven that they're great for the temperate parts of the planet, but they're not good for in the tropics. In the tropics, we'd realize that most of our houses have a triangular shaped roof. It's not by accident. Triangles are great for reflecting light. In the greenhouse, light is your biggest factor that you must control. Not only the amount of light, but also the intensity of that light. When light enters the greenhouse, it tends to bounce around. As it bounces around, it refracts, it bounces around, and it starts to release energy, it starts to release heat into the structure. We need to manage the light more efficiently. Also, we need to manage the way we vent the greenhouses. We have very effective passive technologies, like venturi systems on the roofs. that will allow us to vent the greenhouse and cool the greenhouse using just natural occurrence. Presently, we have 2 greenhouses that we just installing under the Mexican program. And these are going to be active systems where a farmer could now walk in and see. It's a huge investment, but these are super productive. And they could see that technology at its maximum. But we need to also take that simple greenhouse technology and modify it so that it can fit our environment efficiently.
Well said. We're due for our first break. You're watching Agriculture on the Move. Stay tuned. We'll be back soon.
What's in the food you're eating? Do you really even know? All the chemicals and hormones used to accelerate their growth. All the artificial flavoring, sweeteners and colors too. We consume and we don't spare a thought for the damage that they'll do. No, think about the children. Think about the children. How will we save them? Chemicals and GMOs are not the solution. Use organic and join.
Excessive agrochemical use, additives, and genetically modified foods are harmful to health and the environment. Join the good food revolution. Grow, buy, and consume organic. A message from Rise St. Lucia and the Ministry of Sustainable Development with funding from the GEF Small Grants Program, UNDP.
The good food revolution.
Welcome back to the program. With me, of course, the 3 gentlemen, Elvis, Quint, and of course, Constantine. Elvis, of course, is a retired officer. He wants me to say that because he's volunteering his service, of course, to the farmers of this country. He's done a lot of work in the Extension Division. And of course, I'm hoping that he will continue to be a consultant for St. Lucia and for the farmers. Elvis, going forward, as Constantine mentioned, now we are moving forward into a different dimension, looking at the different structures, looking at different technology, high-tech agriculture. And of course, that, in my mind, will be able to get the young persons to come into agriculture, because at the flick of a button, then things can happen, okay? Where are we going now? Where are we now, and where we believe that we can be in the next 5 years?
Okay, now we are at a point where we are collecting data. We are, in a sense, experimenting, doing on a trial basis, to be able to determine what are the benchmarks that we need to establish to get to that level of productivity that we're talking about. I mean, one of the things that we saw in Mexico is that, I mean, the farmers in the very same structure are able to produce in excess of 75 pounds per plant. Okay? And as I was in Extension, I was saying to our farmers, if we could produce half of that, if we could produce 50% of that, right, we would be making a serious dent on the food import bill. Okay? But to get to that 75 pounds per plant, there's some basic information that we require, right? And whereas we could piggyback on probably Mexico and Martinique, sometimes the microclimate is such that we need to have our specific information for us to hit the target, the right target, to enable that plant to produce at its maximum. Okay. You know, so at this point, I see we are at the point where we are collecting information, you know, do all trials to make sure that the technology is perfected, so that the farmers could make the best of it.
From an engineering standpoint, you mentioned irrigation. The management of the irrigation systems, what say you to the farmer that you're bringing on board?
Yeah, irrigation is one of the key components in greenhouse production, because you have a covered structure and it's protected from the rain. So you now have to come in and supply the plant with the required water. What it allows us to do is have a much better control over when and how much water is supplied to the plant. In the open environment, you don't have that control. So at times, a lot of plants get excess water. Other times, they don't get enough water, right? Even when the plant's at a flowering stage. If it's out in the open, the rain comes down and destroy a lot of the flowers, the pollen and everything. Whereas in the controlled environment, we determine how much water, when do we irrigate, and how much fertilizer do we apply, right? So we have the option of even changing the fertilizers at different stages of the plant. That helps you actually not fully control, but influence the growth and the production of the plant. Because you could speed it up and you could slow it down to a certain extent through your irrigation system. So irrigation is extremely important for any protected or indoor agriculture.
What type of irrigation system are you talking about?
Well, most times we use drip irrigation, right? But then in some cases we use micro misters, micro sprinklers, misters, and other forms of irrigation. But definitely drip irrigation seems to be the most effective, especially if you're into things like hydroponics. You have a much more controlled irrigation method. Now, one of the important things about the whole greenhouse from an engineering standpoint, you asked where we go in, right? So we have dealt with the greenhouses for a while now. We have learned a lot and we've gained a lot of experience. Right now we're at the point where we could modify the old greenhouses. We could design our own greenhouses suitable for our conditions. And in doing that, there are lots of stuff that need to take into consideration. When you're designing the greenhouse, it's supposed to make things easier for the farmer. So you need to know what height the greenhouse should be. You need to have an idea of what crops you're going to grow, so the greenhouse structure itself could be strong enough to support the crops. No longer you have to go cut pegs and sticks for tomatoes and cucumbers. Right now you just tie them to the ceiling of the greenhouse. So we're seeing big things for the future. Right now we're able to actually design our own greenhouses for our environment, our conditions. Most of our greenhouses, they are imported, and they're not the most appropriate for our conditions. So even the tunnel greenhouses, there are some modifications we could do right now to make them a lot better, to improve
In your
them.
modification, are you looking at cost of the structure? Because that's one of the things that the farmers are looking at, the cost of establishment, because money is scarce.
Yeah, just a very simple example. For example, a lot of the tunnel greenhouses, they appear to be too short. So simply by raising them, by putting some extension posts, just to get them off the ground, that alone is a modification which could allow you to do tremendous improvements. Because right now we're not just looking at agriculture on the ground, we're looking at elevated agriculture. The taller your plants could grow, the more they should be able to produce. So we're looking at doing some slight modifications to the structures, not breaking them down and redesigning them, just improving them.
There are 2 Mexican greenhouses established on island as we speak. Take us through the management of the structure. The tunnel was not fully enclosed. That structure is fully enclosed. And of course, if a number of equipment in there, the cooling system, fans, etc. Take us through that process.
Okay. The structures, when they were installed, they didn't come with the cooling systems. They came with an antiviral mesh around them that would protect the crop from insects. And also, they had a venturi roof that would allow for passive cooling. We evaluated these structures. We grew a number of crops. Elvis spent a long time under them. And we realized from the data that we picked up that they were not the best. So we modified them with assistance from the Mexican team that work with us. And we've put in extractor fans. The extractor fans are designed to remove all of the air within the structure in 1 minute. We have 7 extractor fans, each with a 1 horsepower fan, a motor on the fan. We have circulation fans, which are designed to ensure that we have the perfect environment around the plant, because within these structures, since there's no wind, there's no airflow, you tend to have a buildup of oxygen or carbon dioxide, depends on which time of the day you look at. Both of them are detrimental to plant growth. And so the circulation fans are designed to ensure that we have the adequate environment around the plant. Also, the structures are able to manage humidity presently. They come with humidity sensors that we've installed, and these sensors are going to ensure that based on the crop that you're growing, you have the correct humidity. For example, tomatoes do not like too much humidity. Why? Because they don't flower, the fruit doesn't set properly
High temperature.
at high humidity. So the humidity of the structures are also going to be controlled. Each structure has presently a 96-foot wet wall, and the wet wall is fed from a submerged well, and the temperature within the well should be oscillate between 23 to 28 degrees Celsius. We have plans, however, to lower that temperature still. The wet wall will allow for all of the air that has to enter the structure to be cooled. So when the extractor fans come on and they empty the air in the structure, all the new air would come in through the wet wall. The air on the outside would be, the equipment is designed to evaluate the temperature within the wet wall and the temperature on the outside and the temperature on the greenhouse to determine how intense the equipment should work.
Hold that point. We'll do for another break.
Yes.
You're watching Agricultural Move. Don't go away.
Pour contrôler maladie cigatocanoué, il nécessaire et bien important pour tenir tout équipement, particulièrement machine sprayer en bonnes conditions. Toujours nettoyer machine après ou servir et mettre en condition bon service même quand l'usine recommandé pour tenir. Depuis ou ka servi chimique pour contrôler maladie figue cigatocanoué, il est absolument important pour protéger corps et prendre en chaque précaution. Opérateur ces machines sprayer ni pour servir habillement qui est bien protégé yo. Servi overall, goggles, boots et gloves pour empêcher chimique toucher la peau et bien expirer.
Pour plus d'informations à sous manière pour traiter et contrôler maladie cigatocanoué à sous plantation et bien jardin ou ça téléphoner département pour ménager cigatocanoué à numéro 451 5491 et bien 451 5894 et bien email yo à bpmu@candw.lc. Commission Salak a sorti Hod Ministère de l'Agriculture ensemble avec Fonds Coopération Internationale et Développement Hod Pays République la Chine Taïwan.
Welcome back. Constantine, I have realized that greenhouse production is very technical, and of course you have been elucidating on some of the technical areas for the management of that greenhouse. Can you continue to tell us a little more so that farmers out there would understand what you're talking about?
Okay, so it may sound very technical, but it's very easy to manage. The setup of the greenhouse is always very difficult. It's a very technical task. But each greenhouse has a controller that is programmed. And the controller now will allow the farmer to be able to adjust the environment within the greenhouse from his cell phone.
Oh.
It will simplify agriculture tremendously. As they are presently set up, the software has not been installed, so we still cannot do that. But the equipment that was bought will allow for that. Now, putting all of that high-tech, expensive equipment aside, our farmers need to move in that direction. And we're not only looking at the expensive structures, but I mean, there are local materials that can be used to lower the cost of setting up a greenhouse. There's forest wood, there's lumber that can be used. There are many new ways of setting up greenhouses. The training component is key, because within the structure, you don't take care of the tomato within the structure as the same way you do it on the outside. You have new protocols, it's a new way of doing things. And like Quint was saying, I mean, we feed the plant according to what we want the plant to do. Within the ministry, we have simulators that would do all of these calculations for the fertilizers and all of that stuff. If a farmer is interested in going into hydroponics, he would come to us, we would plug his numbers and based on where he is into a simulator, and then we would give him a recipe. He wouldn't have to go do all the hard work, all the chemistry and all the hard math. We would do that for him. We are looking at also doing a round of training with the Mexican government that would allow our farmers now to be able to embrace that technology, because it's where the world is going. We don't want to be left behind.
Exactly.
It's simpler production when you learn how to do it the right way. It's more productive, lower cost of production, lower environmental footprint. I mean, it's where the farmers should be looking. That's the light at the end of the tunnel for them. Okay.
Elvis, I know in the old system they're using either beds, right, in the greenhouse, and they have moved to using pots, right? What's the advantage and disadvantages?
Okay. In the tunnel type structures, we were using soil. With these two greenhouses that we got from Mexico, then you will be using, which is a hydroponic system. Now, with regards to tomatoes, our biggest problem with tomato production in St. Lucia is the bacterial wilt. It's a soil-borne disease. So taking the plant away from the soil, you have already solved that problem. Okay, so the hydroponic systems gives you the ability, right, to produce tomato without worrying about bacterial wilt. Okay. In addition to that, it is easier to manage in terms of nutrients. And as a result of being better able to manage the nutrients that the plant is available, it gets, then your yield per plant is supposed to be much higher than the open field. So that is why, for example, the yields in the greenhouses are always higher. That is one of the reasons why it's always higher than the open field.
Okay. Okay. In terms of organic and inorganic management of the greenhouse, what way are you going, Constantine? Are you going the way of organic? Are you going the way of inorganic, or both?
Okay, our farmers need to learn both. Presently, it is very difficult to do full organic production within the greenhouses for some of the crops, because the fertilizers tend to be very expensive. However, some work has been started to look at the use of local materials to produce some of these organic fertilizers, high-valued fertilizers, and some of these eventually can be sold. The inorganic production also is very important. The inorganic production within the greenhouse will allow the farmer now to understand why each nutrient is important. I mean, it would be a nice fairy tale to say everybody would go organic, and I mean, would have perfectly clean food, you know. But I mean, that's not the reality. The reality is that the farmers are businessmen, and they need to make money. So we will be teaching both aspects of it. We will be ensuring that our farmers are trained in both the management of the chemicals and the responsible management of the chemicals, because we don't want these chemicals going into the soils. We want them to stay in the artificial substrates. We want them to be disposed of properly when they have to be disposed of. And we also want our farmers to now to be able to use the materials that are available in the environment, for example, the sargassums and the manures and all of these other stuffs, to cut the cost of production and to make the production also more reliable. Because, for example, if you own a pig pen and you produce biogas, then it means Mr. Odlum could tell you how to take that biogas now and send it into your greenhouse, you know, put a venturi system in, and he could design something where you could now cut your cost of production just by putting a biogas plant for your pigs, you know. So it's a more integrated focus in agriculture, where we focus on our environment, but we also focus on the bottom line, which is the dollars and the cents.
So you use, in other words, your input should be minimal, but you ought to increase your output.
Your output,
and then, of course, at the end of the day. Any final words from you,
Yeah,
sir?
but
One second.
In connection with that, we should also remember that the person who is doing inorganic production, right, it doesn't mean that he too cannot use the techniques that the organic farmer is producing. Once it is giving him the results that he's looking for, you know, and that would also help him to be more productive.
Great.
You know.
Final words from you?
Yeah, well, what I would like to let the farmers know is that right now, agriculture is changing. Right now we have less available land and more mouths to feed. So we need to look at agriculture from a different standpoint. And that's where all this technology and science and everything is coming on. A lot of people are afraid of science and technology, but it's definitely the way forward. right?
I agree.
And I could definitely say our team, we have got a lot of experience in greenhouse production and greenhouse management. So I'm confident that the future of greenhouse in St. Lucia stands a very good chance.
Great. So, gentlemen, I want to thank you. Elvis, thank you. Quint, and of course, Thaddeus, thank you for being here. I know you all have been doing a very good job, and I think you should continue from the school, or start from the school level, and then train the youngsters to take over from the aged farmers as they want to. And remember, of course, agriculture is a business.
Definitely.
Thank you for viewing the program, Agriculture on the Move. I hope you got some good information so that you yourself can start your own greenhouse in your backyard. The information is there, the technicians are available, so please use them. Remember, agriculture is our business. I'm Phillip Sydney saying goodbye and see you again. Thank you, gentlemen.
Yep.
Thank you, thank you. Thank you, comrade.
Thank you.
Agriculture on the move.
Agricole en mouvement.
Agriculture on the move.
Agricole en mouvement.
Agriculture on the move.
Agricole en mouvement.
Agriculture on the move.
Agricole en mouvement.